There are two types of forces, conservative force and non-conservative force. Conservative force means work done by the force is independent on path of the body. So non-conservative force means it depends on the path along which body moves. The example for the conservative force is gravitational force, electrostatic force, that means positive and negative charge, attraction of the positive and negative charge, then elastic force of the spring. The example for non-conservative force is forces of friction, which is always opposes the applied force. Then force of viscosity, everything. So based on the work only, we classify the force into conservative and non-conservative force. Next, we are going to see about conservation of mechanical energy in a free falling body. So mechanical energy means a total energy, that is potential energy plus kinetic energy. Let us we take a body of mass m. It is allowed to fall freely. So it will travel some distance x and reaches the point B with velocity v dash. Sorry, with velocity v only. So the initial velocity is 0 because we are going to drop the ball from the point A and it will travel a distance x and reaches the point B with velocity v. After some time it travels a distance h minus x and reaches the ground with velocity v prime. So what is the total distance from A to C? It is a h. So this distance is x, means this distance is h minus x, which is equal to h minus x. Now we are going to calculate what is the total energy at the point A, B and C. So at point A, the body is at rest. So the velocity is 0. So the kinetic energy is half mv squared. Velocity 0 means kinetic energy 0. But potential energy formula is mgh. That is h denotes the height of the body. So the height of the body is h. So directly we get total energy, which is equal to potential energy plus kinetic energy, which is equal to mgh. At a point B, the body falls freely through a height x and reaches the point B with velocity v. So it travels a distance x and reaches the point B with velocity v. Using Newton's equations of motion, v square minus u square is equal to 2as. So the velocity, initial velocity is 0. Then the velocity, final velocity is v at the point B. So v square minus u square is equal to 2gx. Because why you are putting acceleration as a g? Because it is a free falling body. It is coming down. So when any body which is fall down means towards the earth means a positive g. Then the body is move against the gravity, that is when the body is moving upward means it is we have to put minus n for g. So here in our case the body is falling down, so we take it as a acceleration as a positive, and s is a distance traveled by the body. So velocity squared, which is equal to 2gx. So kinetic energy, which is equal to half mv squared. So instead of v squared you have to substitute 2gx. 2 get cancelled, we get kinetic energy is equal to mgx. Then potential energy, which is equal to mg into height. So what is the height at the point B? It is h minus x. So h minus x. So by adding the potential energy and kinetic energy, we get an equation. Again, total energy, which is equal to mgh. What about the, at the point C? So at point C, a body finally reaches the point C on the ground with velocity v dash. So then considering the motion from A to C, not B to C, from A to C, the initial velocity is 0, final velocity is v square, that is v square minus u square is equal to 2as. A is a acceleration due to gravity g, and s is a total displacement h. Okay, so v square, that is v dash square, which is equal to 2gh. So kinetic energy, which is equal to half m v dash square. V dash square is equal to 2gh. 2 to get cancelled, mgh. At your point C, what is the total height? It reaches the ground, so the height is become 0. So mgh is a potential. Here we get mgh. The potential energy formula is mgh. Here the height is 0, so potential energy becomes 0. So total energy is equal to mgh. For all the three cases, at the point A, B and C, the mgh is equal. That means the total energy is equal. It says that as the body falls, the potential energy decreases and the kinetic energy increases by an equal amount. Then its total energy remains constant. So if you plot the graph, we get that what about this is the origin. Okay, when the height increases, the potential energy is also increases. Then this is the displacement. This is a displacement or the height h. So when the height increases, the potential energy is increases. When the height decreases, kinetic energy also decreases. Then when the height increases, potential energy increases. At the maximum height, the kinetic energy is zero. This is the maximum height, kinetic energy is zero. When the height decreases, the kinetic energy increases. So this graph clearly shows that the conservation of total energy, that is conservation of mechanical energy in a free falling body.